Hi guys, so today we're going to talk about nth roots and rational exponents. So in the past, we've been focusing mainly on square roots. So we have had nothing in the front and kind of that little hook part of our radical. We've had no index here, just like we see in question A, square root of 9. But as you notice it's building, cube root, fifth root, fourth root, so forth and so on, I can have a value there. And we're going to learn how to deal with those different roots and also what we call rational exponents, which are fractional exponents. And they actually come from radicals of different roots. So we're going to go through this do now in class, but you would use your Desmos calculator, or if you have a regular scientific calculator, and you would get these values. So you can see there are a few of them that are nice perfect roots, 3, 2, and 3, you can see there. And then obviously we have some decimal answers as well. We are going to learn how to simplify, just like we did simplifying square roots. So if they want either an estimated answer like we see here, or an exact answer, which would be the simplified radical form, we will know how to do that. Okay. Also, take notice real quick that square root of 9 is 3, and so is 9 to the 1/2. So what we're going to learn is that square root and a fraction exponent of 1/2 are actually identical. And we're going to learn that in a little bit. So let's move along here. I'm going to move myself. Here we go. So basically, whether I go from a rational exponent to a radical or vice versa, as I have giant over here, our fractional exponents, or rational exponents, come from the index of my root and any exponent that is attached to the value or outside. If the whole thing is to that power, I can treat it as such as well. Because if I look at this, the n is always going to be your denominator. The root, the index of your root is always your denominator. And then whatever exponent is with it, so in this case, x is 1, goes on the outside. And then I can distribute that m in, which creates that m over n, as we see up here. And again, I can go backwards as well. That's what they're showing me in the core concept area. So what we're going to learn is how to both evaluate and simplify these expressions. So first off, I'm giving you nice whole ones that we can use pretty easily. Again, the exponent to your value is always your numerator. The root, your index of your root value, is always your denominator. So in this case, it's a second root or a square root. In part B, it's a fifth root. That's the part that's going to go in the hook section of your square root symbol. And that's just a matter of simplifying. Obviously, yes, I can put this in a calculator, and we probably will do that for most of the times, as long as it says I can simplify and approximate or estimate your value. So these ones clearly say without a calculator, excuse me. So again, you would just simply take whatever your denominator is, that is your root, and then you would have power 2 of your value to it. So this would be 1 to the 7th, 81 to the 3rd, 9 to the -5th, 4 to the 5th. And then each of those would be in the roots appropriate to your denominator. Okay, we'll go through these examples in class. But just real quick, if I have a negative root, a negative exponent, remember that means it's in the wrong position. So if it's a whole value, I need to flip it, bring it into the denominator, and use the 1 in the numerator. Just to walk through this one, notice I put the exponent on the outside, just makes it easier. I don't really want to find 32 to a third power yet, but if I can find the root of it to simplify. So for instance, the square root of 16 is 4. I can simplify that and then do 4 to the third power. Makes it much easier than trying to do 16 to the third power and then root that. Same thing over here. I could find the fifth root of 32, which is 2, and then 2 to the -3rd power gets me 1/8. Now, again, using your calculator, you can use Desmos. I just showed you it in the do now. If it says approximate, make sure you approximate to what value they want you to. So 100th is your 2 value places, tenths is a single, thousandths is your 3. Okay, so make sure you're rounding to the appropriate position. And again, we'll go through these. It's all calculator work from there. Okay, now when we get into solving, we're going to need to keep in mind a few things. First, whatever the root is, whether it's positive or negative, is going to affect your outcome of your solution. A even root, we did square roots before. Square roots are even, it's 2. If it was less than 0, you had no real solutions. We had imaginary numbers involved, okay? If it was 0, well, any root, regardless, if 0 is on the inside, it's going to be 0, and that will be your one solution. And if it's a positive number, remember when we did square roots, we had a plus or minus. We had 2 solutions there. The flip side of it is now we're bringing in odd roots. So if I have a 3rd root or a cube root or a 5th root, 7th root, anything that's an odd number, they all have one single answer. No matter what, it is the sign of the answer. Okay, so the root here is going to be a negative value. The root here is going to be 0. And if it's a positive a value, it's going to be a positive value. Okay, so it's whatever the sign of the number is, you will have one answer to it. Okay. Now I can go back and forth. As I said, I can take the exponent and find the answer, or if I want to find the base of it, I just square root it, or sorry, nth root it, I should say. And then that's what's bringing us into our solving. We're going to build on that. So if I have b to the n equals a, and I want to find what b equals, I'm going to take the nth root of it, of your a value, and that's going to get me my b. Vice versa. If I want to find a, I can raise this to the n power to get b to the n. Just like when we had the square root of a, we squared it to get rid of the squares, those square roots, right? So again, this is just some simple simplifying. It's an odd root with a negative number, so that will get me a -6. This is an even root with a positive number. I would have a plus or minus in that case. So again, it's important to know odds are whatever they are. If it's a positive number, it's positive. If it's a negative number, it's negative. If it's 0, it's 0. If it is an even root, that's when you're going to have your different values. Okay, and again, we'll go through those in class. And the last thing is, well, how to solve. When you're solving, it's very similar to the square root method of solving. You want to get the root or the value by itself and then root it to whatever the exponent is. So in this case, I took a 5th root because it was 5 power. In this one, I'm 4th rooting. This is a 4th power. And again, anytime we have an even root, we are going to, there we go. Even roots, we have to put that plus or minus. And again, take note, it might let you give approximate solutions, or you might have to give actual solutions. Actual solutions are those simplified radical forms. Approximate solutions are your decimals. Okay, and we'll go through more practice problems with these in class.